Hello friends, welcome. Today we would be learning how to solve clock related aptitude problems. This is a very important class of problems asked in nearly all competitive exams. So it's very important that we tune in carefully. So this is where the clock problems fit in, or this is where I like to fit them basically. I consider them as a special case of circular track where the track is the face of the clock and of course the racers being the two hands of the clock. Right, so all the techniques that we have learned so far for circular tracks can be directly applied to problems dealing with clocks, and I'll show you in a second where they apply and how to apply those. But before we start, this is one of the very important things which lot of students miss, and this is regarding less with math. This has less to do with maths and more to do with English. And this, but the questions, of course, you have to read the English and translate it to math, so it's important. And the concept is how to tell time. So the time in most of the aptitude problems is not given directly. They won't write this in numerals, 1 o'clock. Instead, they would say 1 o'clock, and then you have to understand that 1 o'clock really means 1.00, 1 hour and 00 minutes. Similarly, all the times till 30 minutes are represented in terms of past. For example, 5 past 1, quarter past 1, which means 1:15, and so on and so forth. After half past, which means after 1:30, for example, we would, instead of saying times in terms of 1, we would start saying times in terms of 2, because we are now closer to 2. This part of the clock, right, as soon as we reach 1:30, becomes closer to 2. And so we start saying how many minutes are left before we reach 2. So for example, 1:45, instead of saying in terms of 1, I would say quarter to 2, which means 15 minutes are left before we reach 2 o'clock. So it's very important you note that. There are two other important concepts which are now being, I can see that in modern problems these two concepts are also used, which is the concept of bottom of the hour and the top of the hour. Top of the hour means the minute hand is right here at 12, and bottom of the hour means that the minute hand is at 6, or it's 30. It's 30 minutes past the hour. So this is how the clocks of the hands of the clock look. The square one, if the square peg represents the hour hand and the minute hand is represented by the triangular peg, then you will see that the minute hand moves much faster than the hour hand. It overtakes the hour hand number of times during the 12-hour period, and this is the concept that all the problems would utilize. This is the basic concept. So now, like I said in the previous slide, I showed you in the previous animation how the two hands of the clock are moving at different speeds. We already know that they travel at different speeds. So let's try to find out what those speeds are. So speed of the hour hand, if we want to calculate that, we know that how much time does the hour hand take to cover these 12 hours? It is 12 into 60. This is the amount of time it takes. And how many degrees are there in the full circle? It is 360 degrees. Therefore, what is the speed of the hour hand? Is 360 divided by 720, which is equal to half degree per minute. So this is the speed of the hour hand in terms of degrees per minute, right? I mean, we are really using the degrees. No funny business here. Simply the degrees covered by the hour hand in 1 minute. What is the speed of the minute hand? We will use the same concept. And how much time does it take the minute hand to cover the entire 360 degrees? We know that, right? It takes 60 minutes. 1 hour or 60 minutes, and the minute hand would traverse the entire face of the clock. This comes to be 6 degrees per minute. So what is the relative speed? Right? What is the amount by which the angle is increasing? The angle between them is increasing or decreasing per minute. The relative speed becomes 6 minus half, which is equal to 11/2 degrees per minute. Right, and we will keep it in this terms. Right? You have to remember it in this terms, because this is, like we said, we always simplify after arriving at the final answer depending upon what's given in the choices. We don't simplify it right here. It's useless. It's just a waste of time. So remember the numbers in this form, in the least simplified terms basically, right. So 11/2 degrees per minute is the relative speed between the hour hand and the minute hand. Right. So we will have to remember this. Okay. So I'll write it here. We'll use it in future problems. Okay. So now moving on. Most of the clock problems which are asked in the exam have to deal with the angles. They deal with the angles. So let's first study what the various angles in a clock are and what are the various angles which the hands of the clock can potentially make. So of course there is this angle which is made by the hour hand. Right? So let's say we are at 2 o'clock and there is an angle which is made by the hour hand. What is this angle? Right. Each hour, the hour hand moves by how much? What is the angle here? It is 360 divided by, there are 12 such sections divided by 12, which means each such angle is 30 degrees. Therefore, at 2 o'clock what the angle would be? It would be 60 degrees. Right? That is one such angle. What's the other angle? The other angle is the smaller one, this one right here. It's the smaller one, and this is actually traversed by the minute hand in 1 minute, correct? So what is this smaller angle? This smaller angle is, this much is 30 degrees and there are 5 sections in this 30 degrees, and this smaller angle therefore is 6 degrees. So these are two important angles, you should remember those. The larger one 30 degrees, the smaller one 6 degrees. Nothing complicated, pretty simple, pretty obvious. Now let's take a time. For example, it's 2:20, right? 2:20 can be represented something like this. Okay, and notice how I draw the hands of my clock. I always make it sure that the shorter hand is within the boundary of the clock. The minute hand or the longer hand is outside the boundary of the clock. I take it outside the boundary of my clock because in the question when I am solving it, when I am drawing the diagrams, I don't want to get confused, right? So you use this technique. Okay, it will help you. It will reduce the number of mistakes because you are short on time. You already know that. So there is a great probability of making mistakes. So use these simple techniques and you will always come out as a winner. So this is very simple. Okay, so let's do 240. Now what are the various angles you can see here? So there is this angle made by between the hour hand at 2 o'clock and the hour hand or the hour hand at 2:20 and the hour hand at 12 o'clock. This is one angle. Similarly, there is an angle minute hand. Then there is an angle right here between the hour and the minute hand. This is very important. We'll identify how to solve this one, right? How to find this angle. And then there is this reflex angle between the hour hand and the minute hand, right? Sorry, not till here, but right till here. Between the hour hand and the minute hand, there are two angles. One is this one, the smaller one, and one is this one. This is just 360 minus this angle. Since it is greater than 180 degrees, it is the reflex angle between the hour hand and the minute hand. The questions would sometime ask you specifically what is the reflex angle between these two hands, and in that case you have to find this angle and not this one. For all intents and purposes, we would focus on finding this angle, but if the question asks you reflex angle, tell this angle. Okay. Now let's try to find out all these angles at 220. Can we do that? What is the angle made by the hour hand from the 12 o'clock line at 2 o'clock? What is the angle? So at each of these positions, the angle is 30 degrees. So when the hour hand reaches 2 o'clock, the angle between the minute hand and the hour hand becomes 60 degrees. Right? At 2 o'clock, the angle between the hour hand and the minute hand is 60 degrees, right? So what would be this angle, okay? This angle past 2 o'clock, right? So what will be this angle when the time is 2:20? So we know that the hour hand traverses half degrees in 1 minute. So in 20 minutes, how much extra would the hour hand cover? It would cover half degree into 20. So this is half degree per minute into 20 minutes. So this angle becomes 70 degrees. So at 2 o'clock the angle would have been 60 degrees. At 2:20 the R hand would have moved slightly and the angle would now become 70 degrees. So this angle becomes 70 degrees. What is this angle? 12 o'clock line, between the 12 o'clock line and the minute hand, it is 30, 30, 30, 30, which is 120. So this angle becomes 120 degrees. Therefore, what is this angle between the R hand and the minute hand? It is 50 degrees. 120 minus 70, which is 50 degrees. And of course, the reflex angle becomes 360 minus 50 degrees, which is 310 degrees. Right? So in this simple case, we were able to solve all the angles. Right? We were able to find out all the angles. Now let's try to generalize this concept. Can we do that? Can we generalize this concept? Let's see. The first thing that I am going to do is, let me write this down, the relative speed, degree per minute. I am going to cancel this 12. I don't really like, from the perspective of maths, I don't really like 12 here. I am going to put 0 here. So far so good. Now, what are the angles? Right? What am I trying to find? I am trying to find the angle between the R hand and the minute hand at h hours and m minutes. That's my objective. And how do we do that? What is the angle between the R hand and the minute hand, at 2 o'clock, at 1 o'clock, 2 o'clock, 3 o'clock? Can we do that? Can we find that? Each of these is 30 degrees. Right? Therefore, the angle at h o'clock would be 30h. The angle between the minute hand and the hour hand would be 30h. Right? So, for example, at 12 o'clock it becomes 0 degrees. At 1 o'clock it becomes 30, 60, and so on and so forth. Right? So, this is the angle between the hour hand and the minute hand at the top of the hour. Now, since the top of the hour, how much time has passed? M minutes have passed. Okay, and in this m minutes, the R hand is catching up with this minute hand, is trying to reduce this angle, right? So we put a minus sign, and by how much is the angle reduced in every minute? This is the relative speed, 11 by 2. So there we go, right? Now another thing to note here is that as the as the minute hand moves, it is at this position. Let's say this angle is theta, okay, and then sometime later it catches up and overtakes the R hand, and this angle becomes minus theta. It's just a matter of notation. The absolute value of angle remains the same in both the cases, whether this number is bigger or whether this number is bigger. It doesn't matter. The angle, if you measure it, it remains the same. In one case, it just comes out, this math comes out to be negative. So we don't really want negative signs here, we don't like those in aptitude problems. So we take the absolute value of this number, and this becomes our angle between the two hands of the clock at h hours and m minutes. And this is very important formula, you should and must remember this. Okay, this 11 by 2 is contained here in this formula, so we don't really need to remember the relative speed, it's just there here, sitting here, right here. Okay, but we still have to remember the angle between two hands is absolute value of the R minus 11 by 2 minutes. This we'll remember. Okay. Now before we move on further, let's try to solve one simple problem. This has been asked in last year's exam, so it's important to see how to apply the formula. Although it's very simple, we are being asked what is the angle traversed by the hour hand, right, by the hour hand, this shorter one, between 8 o'clock in the morning to 2 o'clock in the afternoon. The total number of hours covered is 6, each hour is 30 degrees, therefore the total angle covered is 6 into 30, which is 180 degrees. Very simple. Okay, we didn't really use this formula, but we will in just a second. Now here we are given two times, 220 and 220 by 11 minutes, and we are asked to find what the angle would be at these times. Of course, with our newfound formula, this becomes an absolutely simple job. And what this is, 30, theta is equal to 30, my h is 2, minus 11 by 2, m is 20. Therefore, theta comes out to be 50 degrees. Very simple. Absolute value of sine. So if negative comes here, we just discard that. We don't worry about that, because this would have been negative, but we don't worry about that at all. Okay. Now what's the angle at this time? 30 into 2 minus 11 by 2 into 20 by 11. Again, this number will come out to be positive, so there is nothing to worry there, but we still get 50 degrees, which is to be expected, right? I mean, as I showed you, for most of the times, right, for most of the angles, there are two configurations where the angle would be the same, right? So there are two times where the angle would really be, right, where the angle would really be 50 degrees. So this is to be expected, and then those two times for 2 o'clock, between 2 o'clock and 3 o'clock are these, and the angle is 50 degrees. That is to be expected. Now here, lot of students make mistake when we have to go the other way around. If I am being asked, I am given the angle and I am being asked at what time does that angle appear, then here a lot of students make mistake, and I will show you why. Again, theta, we know it is 50 degrees, that is given in the question. 30 into, we know the time, it is 2 minus 11 by 2 into a into m, right? So m I have to find out. So 50 is equal to, I will solve all this, right? So it is 30 into 2 becomes 60 minus 11 by 2 m, right? If you solve all this, you will get m is equal to 11 by 20 by 11 minutes. This is what the m would come out to be. Now of course, in the choices, if it is given 220, then you would miss that. But we know that 50 degree angle also happens at 220. We already did that in the last problem, in the last slide we already did that. So what did we miss? Why are we not getting 20 minutes here, right? We are missing something. And the thing that we are missing is, as soon as you remove this absolute value sign and you convert into bracket, you have to consider both the possibilities. You have to understand that whether this value is negative or positive, the absolute value would come out to be the same. It would come out to be positive. So as soon as you remove this absolute value sign, plus minus would appear here, which means that whether this value was plus 50 or minus 50, my final answer would have been 50 degrees because of this absolute value of sign. And I have to take that into account. I have to take two values, one plus 50 and minus 50, and find out the m for both the values. And if you solve the m for minus 50, you will realize that it is nothing but 20 minutes. So don't miss that. If you miss it, you won't be able to get your answers correctly, and most likely the examiner would trick you. Now this is one class of problems that we have discussed so far. Those were the problems which dealt with the angle between the two hands and the corresponding time. So that is one class of problem. I mean, we have mastered that already, I would think. Now the second class of problems deals with special cases. What would happen when the angles are at these special locations, or when are the angles at these special locations? One such case is when the hands are together, which means they are coincident, one on top of another. This is nothing but the angle between the two hands being 0 degrees. So let's say that I want to find out when such a case would happen at 11 o'clock, when the hands would be together at 11 o'clock. I want to find that out. Theta is nothing but 0 degrees. I can remove the absolute value of sine. I don't have to put plus minus 0 because it's nonsensical. 30h becomes 11 minus 11 by 2m. If you calculate and solve, you will get m as 60 minutes. What does that mean? What does that mean? It means that the hands of the clock, right, when the time is 11 o'clock, the hands of the clock would be together or coincident at 11:60. Similarly, if I calculate for 12 o'clock, the angle, right, 12 o'clock we know is nothing but 0. So if you put 0 here, m would come out to be 0. So for 12 o'clock, the hands are coincident at this time. For 11 o'clock, the hands are coincident at this time. but the two times are exactly the same. For the purposes of clock, the two times are exactly the same, which means that the coincidence is shared between 11 and 12 o'clock. For each of the other hours, 1, 2, 3, if you put h here, you will get a distinct value of m. But the coincidence would be shared between 11 and 12. So, total number of times such a coincidence would happen in a 12-hour period would be 12 minus 1. It is shared between 11 and 12, and therefore 11 times. Right? So, you should remember this. 11 times in the 12-hour period, the hands of the clock are coincident. Let's see when the hands are 180 degree apart. Can we find that out? Let's take a time 4 o'clock and see when the hands are 180 degree. So, one of the special cases and most interesting case is 6 o'clock. 6 o'clock when the hands are opposite each other. This is 180 degrees, right here. So, let's see what happens at between 4 o'clock and 5 o'clock when such a configuration would happen. 180 is equal to, I will use the same formula, 30 into 4 minus 11 by 2m. I have to find out at what time, at what minute past 4 o'clock the angle would be 180 degrees. So, 180 plus minus 180 is equal to 120 minus 11 by 2m, which means 11 by 2m becomes either minus 60 or 300. Right? So, I will take both the possibilities. Minus 60 I do not really like. As an angle, this is not so good. But we know that for any angle, I can always add or subtract 360 degrees without really changing the angle. So, if I add 360 to minus 60, it also becomes 300. So, instead of getting two different values for plus and minus 180, I really have only one value here, and which is 300, which means there is only one time after 4 o'clock, which is, if you calculate this, if you solve it, you will get 4 hours, 54 minutes and 32, 8 by 11 seconds. Only at this one time, the hands of the clock would be 180 degrees after 4 o'clock. So, the key here is noticing that instead of getting two values, we get only one value for every hour. So, again there would be 12, there should be 12 values for 12 different hours when the hands of the clock are opposite to each other. But there is a catch. The catch is the time, right? The times 5:60 and 6 o'clock, right? So, between 5 o'clock and 6 o'clock, instead of there being two different configurations, there is only one single configuration. This configuration of 6 o'clock is shared by both 5 and 6 o'clock. So, there are only 11 such instances in a 12-hour period when the hands are opposite to each other. In a 24-hour period, there are 22 such instances. Now, let's take the last special case which is commonly asked in the examination, which is 90 degree. Because of symmetry, there was only one case where the hands were in a straight line or coincident for every hour, right? For every hour there was one such case. However, for 90 degree, there are two different configurations of the watch, roughly, right? This is a rough diagram, where the hands would be at 90 degrees. Right? Note that. So, instead of getting just 12 values or for 1 hour, I would get 24 values. Right? Instead of just for 1 hour, I will get two such configurations where the hands would be at 90 degrees. So, in a 12-hour period, there would be 24 such configurations where the hands would be 90 degree to each other. However, again there is a catch. There are two configurations which are really shared between the hours. And what are those two 90 degree configurations which are shared? 2:60 and 3 o'clock, they share one time, and similarly 8:60 and 9 o'clock, they share one time. So, instead of there being 24 such configurations where the hands are 90 degree angle in a 12-hour period, there are 22 such positions, and in a 24-hour period there are 44 such positions. So, note that. Okay. Can we generalize this? can we generally say that there would be, for any angle, let's say 30 degrees, there would be 22 such positions? Yes, we can generalize that. And how do we do that? How do we ask the maths, use the math that we have learned so far to prove that? We can do it very simply. So let's take an example of 30 degrees. So 1 o'clock we know that the angle between these two hands is 30 degrees. At 1 o'clock we surely know, that the angle between the hands is 30 degrees. After how much time would this configuration repeat? This 30 degree configuration between the two hands repeat? It would repeat when the hands have relatively covered 360 degrees. And how long will they take to cover 360 degrees? We know that the relative speed between them is 11 by 2 degrees per minute. So 360 degrees relatively they would cover in 360 divided by 11 by 2 or 720 divided by 11 minutes. So after every this much time, right, if you want to solve it, you can solve it. This would come out to be 1 hour, 5 minutes and 5 by 11 seconds. So after 1 hour, 5 minutes, 5 by 11 seconds, the same configuration would appear again and then again and then again. Therefore, this 30 degree angle would repeat how many times in a 12 hour or a 720 minute period? It would appear 720 divided by 720 divided by 11. This is how much, after how much time it is repeated. In a 720 minute period, this would be repeated 11 times. Therefore, the 30 degree, this configuration where the minute hand of the clock is 30 degree behind the hour hand of the clock would be repeated 11 times in a 12 hour period. Note that. Second thing to note is this 30 degree angle can be formed in two ways. There are really two ways to form this angle. Once the hour hand is ahead of the minute hand, the minute hand is ahead of the hour hand. Second time the minute hand is behind the hour hand. So instead of 11 such possibilities, there would be 22, which we already know. Because of symmetry, when the hands are coincident and when the hands are opposite to each other, because of symmetry, we only have one starting position. Therefore, these configurations, when the hands are coincident or opposite to each other, only appear 11 times in a 12 hour period. Now, everything should be crystal clear. Good. So, now moving on, there are two special things which you should also know. What are those? These are just twists in language which examiners like to use just to confuse the students. I mean, note that all competitive exams are becoming difficult and difficult. This is what we have seen over the years, right? So don't expect normal questions anymore. Expect sudden twists. Everyone is trying to do something different, something more intelligent. And examiners are using these two terms, crossing and overlap. Overlap happens exactly at top of the hour. Crossing would happen a little bit later. Therefore, the number of time crossing happens is one less than the number of time overlap happens. Notice that. There is a difference between when the hands are overlapping, it happens 11 times in a 12 hour period. When the hands are opposite, that also happens 11 times in a 12 hour period. And the hands are in a straight line. Either they are overlapping or they are opposite to each other. They are in both of these cases they are in a straight line. So they are in a straight line 22 times in a 12 hour period. Now to sum up, let's try to use all the concepts that we have learned so far in this class here in this problem. So here we are being asked, when would between 4 o'clock and 5 o'clock the minute hand of a watch be 13 minutes ahead of the hour hand? 13 minutes is how much? We already know that, you should know that. Each of those minute spaces, that the space covered by the minute hand in 1 minute is 6 degrees. Therefore, 13 minutes really means 13 into 6 degrees, which is 78 degrees. And now we can use our formula. Absolute value of 30, h I know is 4 minus 11 by 2 m. I have to find the m. I can do that. I know how to do it. This becomes plus minus 78. I remove the absolute value sign. 120 minus 11 by 2 m. I solve for m. There are two values of m that I will get. One from plus 78. One I get from minus 78. And those two values are 36 and 84 by 11. But again, there is a twist. And the twist is that the examiner is only asking you for the position for the M when the minute hand is ahead of the hour hand, and you have to know that, right? You have to know it from the question. Minute hand of a watch is 13 minutes in advance, right? Note that. So in advance of the hour hand, and that would happen, right? So these are the two times. This is roughly 8 minutes, right? And minute hand is behind the hour hand. We don't want that, so we'll cancel this and we'll only retain this value when the minute hand is in advance of the hour hand. 36 minutes. Now in the subsequent classes, we would discuss more advanced problems, right? Problems which deal with the 3 hands of a clock. My clock has 3 hands. Problems which deal with when the hands of the clock are exchanged. What happens when, right? Those are the kind of questions which are increasingly being asked in the exams. Unfortunately, right? But fortunately for those who are watching our videos, so do subscribe. Right? So those problems we will discuss in the next class. In the subsequent class, we will be discussing problems related to slower and fast clocks. Those are also very important, asked in all examinations. Right? So that is my plan for the clocks. So if you want to tune into those, like, don't worry about the problems. These problems I'll mention in the comment section, so you can solve it. But if you're not able to solve it, don't worry. We'll solve it in our next class. So if you want to solve these kind of problems and learn more, then do subscribe to our channel. Thank you very much.